Hello everyone. This is a video regarding our IRE project, which is on aspect-based sentiment analysis. We are team 34. I'm Akshata Jha and my teammates are Shubham Ghia and Juhi Ghosh. Sentiment analysis is increasingly viewed as a vital task, both from an academic and a commercial standpoint. Sentiment analysis basically helps in identifying attitude of speaker with respect to some topic. Nowadays, machine learning, various NLP techniques and text analytics are used to extract relevant information from a review or a sentence. There are two types of sentiment analysis: subjectivity or objectivity identification and feature or aspect-based sentiment analysis. The majority of current approaches, however, attempt to detect the overall polarity of a sentence, paragraph, or text span, regardless of the entities mentioned, example, laptops or restaurants, and their aspects, example, battery, screen, food, service, etc. Our task was concerned with aspect-based sentiment analysis, where the goal was to identify the aspects of given target entities and the sentiment expressed towards each aspect. There were 4 subtasks in this problem. First was aspect term identification or extraction. Now, given a set of sentences with predefined entities, identify the aspect terms present in the sentence. For example, I like the service and the staff but not the food. The aspect terms in this sentence are service, staff, and food. Second subtask was to identify the aspect polarity, in which, say for a given set of aspect terms within a sentence, we determine whether the polarity of each aspect term is positive, negative, or neutral. Example, I like the service and the staff but not the food. Here, the aspect polarity of service is positive, for staff is positive, but for food, the polarity is negative. The third subtask was aspect category detection, in which we were given a predefined set of aspect categories, which were food, service, price, ambience, anecdotes, or miscellaneous. We identified the aspect categories discussed in any sentence. So, as in the previous examples, if we go by the example, I like the service and the staff but not the food, the category detected here is service and the food. The fourth subtask was to identify the category polarity. Given a set of predefined aspect categories, we determine the polarity of the category. In this example, the categories are service and the food, and the polarity of these categories. For service, the polarity is positive, and for food, the polarity is negative. For our project, we have referred mainly to 2 papers. The first one is by Subrata Mukherjee and Pushpak Bhattacharya. It's on feature-specific sentiment analysis for product reviews. The second paper is by Poria and Cambria, which is a rule-based approach to aspect extraction from product reviews. We use the following tools for our project. The first is POS tagger, which gives us the part of speech tags for any sentence for all the words in the sentence. Next is the Stanford parser, which extracts the dependency relationships among different words of a sentence. The third tool that we used was TextBlob. It is a Python library that identifies the polarity of the aspect terms. The fourth tool was the WordNet. Now, WordNet is a lexical database for the English language, which contains all the synonyms, the term definition, the antonyms, etc. The approach that we followed to solve this problem was as follows. First, we developed rules to extract aspect terms from a given review. We use Stanford dependency parser to extract all words that are noun and have the relationships adjectival complement, agent, adjectival modifier, direct object, a nominal subject, a passive nominal subject, the object of preposition, and an open clausal component. Some other rules were that we identified the list of all the terms that were adjectives and all the terms that were nouns. All words which were related to the aspect term up to a depth of 2 in Stanford dependency relation and present in the list were extracted as quality defining terms of the aspect term. Next, we used TextBlog library in Python to determine the sentiment score for each aspect. After this, we created a dictionary of aspect categories using the corpus developed by Cruz and Garcia. What we did here was, we extracted sentences having implicit aspects and then extracted all their implicit aspect categories and created a lexicon. For each aspect under every aspect category, all its synonyms and antonyms were also obtained from the WordNet. Why this was important is, the food is expensive, the category is price. Say the sentence was the food is inexpensive, then also the category would be price. After extracting the aspect terms and its describing words from review, the describing words were looked up in the lexicon created. Depending on the category of the describing word, the aspect term was categorized. The similarity of the aspect term with the aspect categories was also taken into consideration. If the similarity score between an aspect term and a corresponding category was greater than 0.5, then that aspect term was assumed to belong to that particular aspect category. Next, we determined the aspect category polarity. To detect the category polarity in a review, all the aspect terms belonging to a particular category were clustered together, and all their sentiment scores were summed up and normalized. If the entire score was greater than 0, then its polarity was positive. If it was 0, then it was neutral. Otherwise, it was of negative polarity. The results obtained were as follows. For aspect term detection, our F score was 0.375. For aspect category detection, our F score was 0.496. For aspect polarity, the accuracy was 52%. For aspect category polarity, our accuracy was 51%. The challenges that we faced while implementing this project were, first of all, identifying the aspects. Getting accurate aspects itself is a big challenge. The nouns are not always aspect terms. The second was identifying the term polarity. Anaphora resolution posed a high problem while identifying the aspect term polarity. Aspect-based sentiment like sarcasm and contrastive conjunctions, which altered the meaning of the entire sentence, were not taken into consideration. The errors in POS tagging itself and Stanford dependency parser percolated down and affected our accuracy too. The conclusions that we derive are as follows. The proposed framework leverages on common sense knowledge and on dependency structure and is unsupervised. The work exploits associations between the opinion expressions about various features that form a coherent review using dependency parsing. In-depth analysis of dependency relation does not seem significant for now. We do not detect sarcasm or humor in our system. Although the results that we obtained were decent enough, we can improve our work further. To extend it, we can discover more rules for aspect term extraction. We can combine existing rules for complex aspect term extraction. We can detect conflict statement for sentences that do not have either a clear positive or a negative opinion. To extract aspect categories, dictionaries created can be more noise-free. and hybrid approach or supervised classification can be used for better performance. Now, I would like to give you a demo of our project. This is the web interface of our project, Aspect-Based Sentiment Analysis. This is the area where we can enter a single sentence to be parsed. Say, for example, we enter something like, all the appetizers and salads were fabulous, the steak was awesome, and the pasta was delicious. Now to get the aspects, we click on the Get Aspects button. Once we do that, we get these results. It says extracted aspects from sentence. The aspects are pasta, appetizers, steak, and salads, all the words that are in bold. We also get the words that describe these aspects. Delicious describes pasta, appetizers are described by fabulous, salads is described by fabulous, steak is described by awesome. To get the category of these aspect terms, we click on the Get Category button. Once we do that, we get this is the output, where food and anecdotes and miscellaneous describe the category of the sentence. We also get the polarity of the category. Food is positive category, and anecdotes or miscellaneous also has positive category. What we can see here is the XML output. This is the sentence. We can also see the aspect term and its polarity. We can see the category and its polarity. This brings us to the end of our demo and also this video. I would like to thank you all for listening to our project. Hope you liked it. Thank you.